everybody. My name is Alvarius, and together with Justin over there, 2 years ago, we started building a fully on-chain game. And we quickly had to realize that the developer experience of building fully on-chain games sucked. We spent most of our time with writing boilerplate code and network synchronization code. Nothing that had anything to do with the actual game that we're building, but just general stuff. And so, after a couple months of frustration, we decided to build a general framework to solve our own problems. And so we started working on mud. When we got started, our assumption was that there's enough people working on scaling Ethereum that at some point the gas limit of Ethereum won't be the limiting factor for the complexity of on-chain apps anymore. And so we started with a thought experiment. What would happen if 1 billion gas per second was the norm? And so we didn't want to limit our imagination for the types of apps that would be possible if that was the case, and the developer experience of what it would look like to build these games. And so we started Mud1 as an experiment. What if we put ECS, which is a pattern in a very popular pattern in traditional game development, what if we put that on chain? And it worked, at least almost. The developer experience was on a fully new level. It allowed us to build much more complex apps much quicker. As an example, last year, we put Minecraft on chain, and building the initial prototype only took us 2 days because all of the complex stuff was already abstracted in Mud. But I said almost, because we also ran into limitations quite quickly. We ran OPCraft on a testnet because in terms of gas, it wouldn't have been feasible on any mainnet. And even on a testnet, we ran into state bloat issues quite quickly. After 2 weeks of playtest, loading the initial state for the game already took like 20 minutes. But once we got a taste for that developer experience, it would have been really hard to go back to custom networking and vanilla Solidity. And because Mud was fully open source, there was a community of builders that started forming around Mud. And so we knew that we're not alone. And when we first started building Mud, it was mostly to solve our own problems, but we then realized that Mud could be a tool that anybody could use who shares our ambition of building complex on-chain apps. And so early this year, we decided to take all of our learnings from the first version of Mud and from all the games that were built with it, and we started working on Mud2. Oops. Mud2. We released the first preview version of that earlier this year in spring, and more teams started using it. And among them, a couple of venture-backed game studios and professional game studios who were betting their next title on Mud. And so with all these teams pushing for production, we knew that it's time for an audit. And so OpenZeppelin is auditing our code right now, and we're hoping to have an audited and stable release early next year. But why is it that all of these games, all of these projects are using Mud? It's because it allows them to focus on their game design, which by itself is already hard enough. They don't have to reinvent the wheel by writing their own networking codes, state synchronization logic, account delegation, on-chain hooks, etc. All of that and much more is already abstracted in Mud and solved for you. Oops. Mud is modular. The core of Mud is highly efficient and highly optimized and being audited right now, but we're still continuously adding more functions and more functionality with modules that you can install in your on-chain app. And the Mud protocol is separated from the Mud framework, which makes it very easy to build new client integrations. And we already have a number of web-based client integrations ready, and there's a number of teams working on integrations for Unity and for Godot. And with the second version of Mud, we also really focused on gas efficiency. And we managed to bring down the gas cost by around 90% compared to the first version of Mud. But the most important reason is that Mud feels like magic. The flow state that you get into when you're working with Mud is hard to quantify and it's hard to put in words, but you have to experience it yourself. And lucky for you, we're running a workshop later today, and I would strongly recommend all of you to go there and come feel the magic of Mud yourself. And with that, I would like to hand it over to my co-founder, Justin, who's going to tell you about some more exciting stuff we've been working on.
Press the clicker.
All right, sick. I have to be louder than the other room. So I've heard Lattice has been working on some secret shit. The reason we have been doing stuff in secret is not because we want to LARP like the secretive drop. It's just because we weren't sure we were actually going to pull it off. And it's really embarrassing to say you're going to do something and then revert it. That's what happened with Mud 2. We said we would give all of that and it would take us 3 months. And a year later, it's finally stable and in the process of being audited. So we're way more careful about promises now. At Lattice, we're really deep into obscure computing history. One person that has inspired us a lot is Alan Kay. So if you were there at the pre-assembly, I talked a little bit about Alan Kay. Alan Kay was at Xerox PARC. He has a bunch of sayings. One of them is that if you want to predict the future, you should just invent it. That's the most predictable, that's the best way to actually predict the future. Another thing he says that I find not very much known is that he says that the whole concept of programming languages is bogus in the first place. And an exercise to the reader why he says that. But in the process of kind of working on computers and trying to make them less obscure, he invented object-oriented programming and so forth. But the thing that really frustrated him is that computers at that time were actually not that fast. And so people were committing a failure of the imagination on how should we deal with computers? So at Xerox PARC, they built computers that cost inflation adjusted about $200,000. And they're like, oh, we can do all of these things. And people would tell them, well, but it's too expensive. Nobody's ever going to do that. And of course, they were right. Steve Jobs visited Xerox PARC at some point. So the graphical user interface and the rest is history. So he has this quote that goes people who are really serious about software should make their own hardware. And it really kind of after having said that, the thing he did, which, still blows my mind today, he was okay, we have all of these computers, but what would make it such that a kid, a 5-year-old kid could use a computer? And he basically invented the iPad. So this is the Dynabook, I think 1970 or something like that. He was way ahead of his time. And in order to build a Dynabook, they had to do a bunch of crazy stuff. What you don't see on this picture is the Dynabook actually doesn't have its own processor on itself. It was connected to an external computer. They invented Smalltalk, an object-oriented programming language, and they were basically living 10 to 20 years in the future. When you look at the iPad, actually the iPad in some ways is worse than the Dynabook. Better in many ways, but worse in others. So when we think about this fusion between hardware and software, being able to do hardware and software together allows you to temporarily or maybe permanently live in the future. This used to be a little bit controversial, but now that Apple pulled their migration to Apple Silicon and were able to blow every single computer out of the water, people kind of believe this. And now when you see software companies build their own chips, Google is building their own TPUs, Tesla is building their own AI computers. Nobody frowns at the idea of doing this. It just seems obvious. Of course, you have to be careful when you start integrating hardware and software together because you start breaking compatibilities with other stuff. But it's generally an interesting tactic, if not strategy, to have if you're trying to build products that most people think are not possible today. And when we apply this to the blockchain world, the kind of internal separation we have at this is the idea of okay, there is such a thing as blockchain hardware. It's the stuff that's hard as fuck to change. It's the kind of stuff okay, when people have agreed on it, we just have to stick with it. Hardware is also the stuff that determines the performance of your application even more than the software itself. You can come up with clever algorithm, better programming language, write everything in assembly if you think you're a genius. But at the end of the day, the hardware is going to determine what your performance is. And so the way we've been thinking about it is that everything that lands on the left of the blockchain interfaces, on the left of the EVM, JSON RPCs, and so forth, is software, and the thing that lands on the right is hardware. So Lattice, at least with the stuff we've been doing publicly, has been very firmly landing on the left side of this graph on software. So we've built Mud, we have done some experiments with Phi, a new kind of EVM programming languages. We built new deployers and systems and blah, blah, blah. But the right has always kind of really interested us because it feels like the forbidden stuff. You're not supposed to touch that. And it's not a new thing. 2 years ago, in Q4 2021, we're actually one of the first Arbitrum and optimism fork on the Gnosis chain working with XDAI. So XDAI deployed it. We told them, hey, can we use it? We made some changes to the code. Actually found I found a critical exploit in Arbitrum, but they said it was not a critical exploit, so I didn't get my bounty. I'm still a bit sore about this, but it was not a smart contract exploit. It was like a client protocol exploit. Q2 2022, so 2 summers ago, we deployed actually the first Bedrock chain. So Bedrock is the new version of the Optimism protocol outside of OP Labs. They came visit us in New York, and they were kind of like flabbergasted that we had a Bedrock testnet before they did, because they were just running it in like developer mode because it was not ready. We were just trying to play with stuff. In Q3 2022, we built OpCraft and we deployed it on what now Optimism named as like the OP stack. It was just a fork of Optimism. And it was pretty interesting because at that time, people like this notion of, we're just going to have an infinite amount of chains and an infinite amount of gas didn't seem real. Like you have one mainnet, you have maybe a couple of layer 2s. They work very clunkily together. But we firmly believe that these limitations were temporary. One thing that is not on the slide is that it's there. We have our testnet, the Lattice testnet. It routinely does more transactions than layer 2s with people running their playtest on mod. So we've been doing that stuff for a long time. We have like hacked on some stuff, but we never really took it seriously. Like, what if Lattice shipped hardware to production? Because we keep telling people that come to, like the 0xSpark residencies or talks or whatever, just not worry about the gas. They just don't worry about the gas. The problem is like, you can only say this for so long because at some point people want to just like put their game out for real, right? It's not you're not making a meaningful step towards building an autonomous world if you're running on testnet all along. So about 9 to 12 months ago, we're like, okay, if we take this seriously, like if we take the challenge of bringing these applications out of testnet mode, what do we do? And I don't know what my next slide is, so we'll see. But okay. Oh, cool. Okay, we're announcing something. Yeah. So we've been working on this thing called Redstone as the first rollup with Plasma data availability. So we dig really deep into Ethereum history, took out some good ideas that people stopped working on a while ago, and instead focused on rollups. And we're like, if we take some of the old ideas around, data availability challenges made on layer 1 and all of that, you can actually drastically reduce L1 security fees, which mostly comes from posting data on Ethereum, without introducing like new consensus, data availability committees, private groups of companies that are supposed to make your data safe, and so forth. This technology applies to ZK rollups and optimistic rollups. We don't really have a preference over that. We just really wanted to work on the data issue. So Redstone specifically, the first instantiation of this protocol, is an optimistic rollup based on the OP stack. It has extremely cost-efficient fees. We don't rely on new consensus, new permission data availability committees, restaking, or any new protocols. It just uses Ethereum from beginning to end. So it was designed to be as simple as possible. We actually rewrote it 3 or 4 times to decrease the diff on top of the OP stack, because we knew that anyone can like fork some code and change it and claim they have something, but to bring it to production, to audit it, to make sure it's secure and stable, you actually need to be quite serious about the changes you make to whichever tested system you start from. We've worked with OP Labs on committing to bringing Redstone to the superchain. So what this means is we don't want to be in the business of building layer 2s and then kind of like running the security council, giving the upgrade keys, putting some form of like corporation in the Cayman Islands so the SEC doesn't sue us. So we've committed to transferring the upgrade keys of this network to the Optimism Collective, so Lattice can focus solely on infrastructure and protocol design. And for now, like security keys are shared with the Optimism governance. So the way Redstone works is you have your trusty layer 1, Ethereum. So in a traditional rollup, the way you use Ethereum is you use it for ordering and for posting data. We only use Ethereum for ordering. So every time there's a block on Redstone, we post its inputs, so its transactions, but instead of putting them on Ethereum itself, we hash them, we make a cryptographic commitment to them, put them there, and then the layer 2 is derived by loading the data. So a lot of the complexity comes in loading the data, right? Because the whole point is if you load data from outside Ethereum, how do you make sure this data is available? So for us, we don't try to actually solve this problem there. We actually put the data of our Redstone testnet right now on AWS S3. It could totally go down, it could be rugged, we could remove it. The magic comes from this second protocol we've built called the Data Availability Challenge contract. So the idea is that every single commitment that is posted on chain can be challenged by anyone. You can even challenge a hash that is not part of the chain. You put a bond on, and then a data availability challenge window opens. During that window, anyone can provide the data behind the commitment, burn the bond that was put to be able to request it, and of course spend a bunch of money on that. Or if no one provides the data, there's a timeout, the bond is refunded, and the commitment is removed from the chain and ignored. So the thing that's interesting here is it's mostly about game theory. If the operator of the chain is making the data available, whether through peer-to-peer, S3, or any other protocol, you know that if you're going to challenge them, they'll just update the pre-image, right? And then both people lose money, so 1-to-1 cost ratio. But if there's actually some form of protocol failure, data withholding, or whatever, it's really easy for the community to get together, because we built a lot of tools around it, and start challenging the commitments that have been removed and then withdraw from the chain. So you can have like a two-step exit. If the data is removed, you coordinate with the community. The price to challenge data is about $80 right now. So it's like not insurmountable to get together and find $80. You challenge the commitment, you withdraw. This idea can be applied to ZK rollup, optimistic rollup. It's basically kind of like agnostic to the technology. We did not invent this. This is an old idea from Plasma. The thing that is interesting is Plasma didn't reach such popularity because the whole system was like not as good as it could be from a generality perspective. But the components that make Plasma, some of them were really well designed and thought out, and we just were like, okay, let's look at history. What worked well there, and we took it out, we re-implemented it, and that's how we built Redstone. So some words on security and liveness. Security, which is, can people steal your funds? This is not our job. All of the security is enforced by the original code of the OP stack, and upgrade keys and all of that are given to the Optimism Collective. Liveness on the other side, which is, can you reconstruct the chain? That is the thing that Redstone basically like innovates on. We can still get liveness with much cheaper fees. Of course, there's a bunch of like interesting edge cases that happens. What happens if outside of the data availability window, some of the data disappears? Well, you're in big trouble. So Redstone actually relies on people running nodes much more than other rollups. So it's going to be an interesting challenge for us to get people to run more nodes than classical rollups, where at the end of the day, yeah, you can run nodes, but nobody does. So that's like an interesting area of research. The thing that is, that works really well with our use cases is people that want to play on-chain games or worlds or whatever are really interested in having the data locally because the game goes fast. So we can find some like interesting trick there where everybody actually starts saving the data, not because they're altruistic, but because it makes them such that they can play the game better. So work in progress. Coming back to the data availability, it's really important for people to be able to detect that A, the data is there or not, B, be able to challenge it, and C, be able to have like an overview of the system and probably make it automated, because you don't want to like manually watch the chain. So we built a bunch of CLI tooling around auto-challenging, auto-resolving. They can all be self-hosted. Most of them don't even require running a full node on Ethereum, which is usually a huge burden. We've built a data availability challenge dashboard where with a GUI, you can find commitments, challenge them, resolve them. It's all based on Shovel, which is an extremely efficient indexer from our friends at Index Supply. So the way Shovel works is it doesn't actually require a full node. It can use a full node, but it can also download blocks from this lovely little API called the Block API. And I think it's interesting with the Block API is that A, it is extremely fast and cheap to run for the people at Index Supply because it uses Cloudflare in order to deliver Ethereum blocks by slightly changing the protocols to make it cacheable. And B, it's completely verifiable. If you get a block from the Block API, you can very easily verify that it's not like tampered with. So with all of these tools, anyone with a laptop or like a $5 DigitalOcean droplet can make sure the chain is available. We could even bundle all of that into a web browser. And when you're playing SkyScribe, you actually check data availability. Cool. So take these numbers with a grain of salt. It's the first version. It depends on each application, but for SkyScribe, we're seeing about 95% cost reduction per match, mostly by decreasing the amount of data that's posted on layer 1. There's a lot of improvements to be done there. We still deal with commitments naively. We could Merkleize them. We could do like vocal proofs around it, etc. We could probably bring this number down by a lot. So it's funny because the website is not there, but it's actually live today on the testnet. So if you go on redstone.xyz, we have documentations, bridges, the dashboards, auto-scaling RPC. Another thing to say there's no on the slide, is Lattice spent a lot of time building an infrastructure team. So we took this seriously. We're not going to be like, oh, let's just run some Docker containers on DigitalOcean. We know that if people deploy on the blockchain, they want it to be up, especially at a time where rollups now are not sufficiently you can run nodes, but because sequencer is still very much centralized, you want the person producing blocks to be always online. So, spend a lot of time on this. And it comes with all the tooling that was on our previous testnet. So mud indexer fleets and so forth. It will be closer to what the production release will be. So if you are someone who builds on mud and deploys on our testnet, deploying on the Redstone testnet is probably going to be closer to what your users will experience when you run in production. Users have to bridge funds from L1 to L2 The layer 1 of the Redstone testnet is Holsky, the new Ethereum testnet. So yeah, we're very much seeing this first release of the Redstone testnet as not necessarily a replacement, but an evolution of the Lattice testnet. Skystrife will be running on Redstone when going live. Andy and others will tell you more about this. And we are laser focused on pushing to mainnet for 2024. There used to be a date there. I removed it. You should always be careful about putting dates on talks. So we're working on it. And you can go on Redstone XYZ or send questions. Reach out to @LatticeXYZ on Twitter with questions. Thank you, folks.